Hi, my name is Farhan Mansoor, and this is my detailed presentation of my final project, Symptoms Checker, for the CSCI E-90 course. So the goal of my project was to create a test bot, chat bot, using Amazon Lex service, which will interact with users and ask them about any physical symptoms that they're experiencing, and based on their input, it will try to predict um, if predict any disease that he or she may have. So just to demonstrate how it works, I'm just going to show you this test bot, and I'm going to try to interact with it. So what I have is I have set it up a sample utterance. So if I, let's say, ask about, can you check my symptoms, it will ask me what are my most severe symptoms. So let's say go with headache, fever, dizziness, nausea, things like that. There's a follow-up question. It will ask me if there are any other mild symptoms that I'm experiencing at the moment, and I can say cough, and it will try to guess any disease that I may have. So in this case, it's predicting that I may have pneumonia. So the way it's working in the back end is, as you can see on the left hand side of my screen, I have created a couple of slots to capture the symptoms. So in this case, I have top symptoms, which is basically capturing the input of the first question, which are the severe symptoms. And then the answer to the follow-up question about mild symptoms are getting saved under the other symptoms slot. And when I was creating the slots, I used a custom slot type symptom, where I actually listed all the possible symptoms that I might expect the user to enter, which is also something that the model can predict easily. Then what I did is I connected it to the Lambda function that can handle the user inputs and send appropriate response to the bot. So in this case, I'm calling my Lambda function predict disease. Now if I go to my Lambda function, as you can see, so what I have here is I have I'm setting up the environment first. So I have the endpoint, which I'll get to in a minute. This is basically the model endpoint made by SageMaker, which is being invoked by the Lambda function to get prediction based on the user's input from Lex. So initially it's initializing those endpoint name, runtime, and also I have a couple of lists, which is kind of listing all the possible symptoms and all the possible diseases that we're dealing with. This could potentially be also saved in an S3 bucket and loaded from there, but I have it inside as variable in the Lambda function. In the Lambda handler function, what I'm doing is I'm basically getting the top symptoms, and which is the answer to the first question that the bot is asking, and I'm also getting the answer to the second question, which are the mild symptoms, and combining those two lists, because that's kind of the master list of all the symptoms, and since the model that I made in the back end only accepts numerical value, it doesn't accept strings, I have to convert these symptoms to a coded label. So this is where this list comes into play. So I'm using this list because that's the class label that the models are also using, and I'm using this master list to get the code or the index position of the symptom, to get a numerical label for all the symptoms that the user has input. Now, I added a constraint where if the user enters less than 3 symptoms, so 1 or 2 symptoms, it doesn't really predict, because the prediction is no longer accurate that much. So I'm sending a default response, which just says, sorry, I was unable to diagnose your symptoms based on the given information. But if the user enters more than 3 or more symptoms, then I do go ahead and try to get the prediction using a model. So the way it's working is if it's if it's greater than 2 symptoms, but it's still less than 5, because the model takes at most 5 symptoms when it tries to predict it. So, which I'll get to in a minute how the model is working at the back end. But the model only accepts at most 5 symptoms. So the idea is to send the top 5 symptoms to the model to get the prediction. So for the scenario when the user only inputs 3 or 4 symptoms, I'm kind of filling the ones with the missing. So 20 represents the missing symptom. So 20 is the label for a prognosis that doesn't have that 4th or 5th symptom. So and then I'm sending that symptom list to the endpoint. So what it's doing here is it's invoking an endpoint that is talking to the model in the back end, and I'm sending the list of symptoms as a text format, in text format, to get a response back. Now in that response, the way it's structured, I'm doing this a little bit of parsing to get the disease code, which I'm using to actually find the disease and display the disease as a message. So then I'm sending the message to the Lex as a response, and this is the response format, and that's getting sent to the Lex bot. Now the way I'm using SageMaker in the back end is what I did is I used the notebook instances of Amazon SageMaker, and I created a notebook instance where I did all my processing and modeling work. And the data set that I used is one that I found in Kaggle, which looks like this, where you have a list of symptoms and a possible prognosis. And I used only the top 5 symptoms to do the modeling. And as you can see, for some of these data, they don't have a symptom 4 or 5, right? So that's where it's getting replaced by missing to do the model. Now, if I quickly go through the notebook, it's basically what I'm doing is I'm creating an S3 bucket directly from the SageMaker notebook, and I'm creating this bucket so I can store all the test data set. There are some data sets here that I'm uploading to the S3 bucket. And what I'm doing is I'm creating this combined data frame using Panda, and then I go straight to the modeling part. So I'm picking the top 5 symptoms, I'm recoding it so that since SageMaker's KNN functions do not accept categorical values, so I have to encode them to numerical labels before I can call the modeling function. So what I'm doing here is the encoding part of it, and I'm also saving the encoding as the JSON file. And this is what basically you see when I went to the Lambda function. You see this class labels for each symptom and disease. So that's coming from the encoding from the model. Same thing I'm doing with the disease values, because it's also categorical. So I'm changing encoding that, and also saving the labels as JSON file to S3 bucket. After that, I'm splitting the splitting into train and test data using sklearn, and preparing the data set for SageMaker's input function. So one requirement for a SageMaker's input function is the response column has to be at the beginning of the data set. So that's what I'm doing here. I'm inserting the Y or response data at the beginning of the data set before I send that to the SageMaker's training input. Same thing I'm doing it with for the testing data, so training data and the testing data. And then I created this function which makes the KNN model based on some hyperparameters. The hyperparameters that I'm using is I used k equals to 1, and I'm using 5 for feature dimension because there are 5 symptoms that I am using, and I'm using k equals to 1 because when I tried with other k values it didn't work as good as k equals to 1, and I'm using predictor type as classifier because we are trying to classify the disease. And I'm sending these hyperparameters to this function, which then calls the estimator function of SageMaker, downloads the image of KNN image, and then it basically fits the model right here, and then it returns the fitted model. So I'm using this to build the KNN estimator, which took like a couple of minutes each run. And then after I built the estimator, I then deployed it using the deploy function, which basically makes the model available as a service for other tools like Lambda. And just to test it out, I'm testing it here. I'm passing it as an array of numerical labels for all the symptoms, or 5 symptoms, and then I'm getting the label for the disease back, so 8, which I think in this case, I think it's cold or something like that. And just to demonstrate the endpoint, so the endpoint is here, and you can also find the endpoint. If I go down, like SageMaker, I can also get the endpoint. Yeah, right here. So that's the endpoint name that I'm using in the Sage, in the Lambda function, which is right here. So that's pretty much how it's kind of working in the back end. So Lex is sending those user inputs via Lambda function, and the Lambda function is taking those inputs, invoking the model endpoint, which is made by SageMaker, and it's in KNN nearest neighbor model. And once that model is invoked, it sends back the prediction to the Lambda function. Lambda function reads the prediction, converts to a disease label, and then sends back to Lex, which then Lex displays to the user as pneumonia. Now I could add more utterances to these test bot, and the prompts could be more developed, so make it more user friendly and ask more thorough questions, which may improve the prediction model. So may improve the prediction. So that's pretty much how I built this. A couple of things. I did have to give Lambda function access to SageMaker by going to the policy. Configuration, yeah, so right there I had to give it access to the SageMaker, full access, so that it could invoke those model endpoints that was necessary. So that's pretty much it. Thank you for listening to the presentation.